Welcome to the Professor Insight podcast, where we unpack the complex world of artificial intelligence, neuroscience, and emerging technology, and make it practical for business, research, and everyday thinking. As always, we would like to acknowledge that this podcast is fully powered by AI tools from content creation and script writing to voice generation. This is all done with human supervision and manual curation. Today, we're kicking off a special two-part series that dives into one of the most essential skills in the AI era, prompt engineering. This two-part series is based on the prompt engineering resource authored by Lee Boonstra at Google. Whether you're using ChatGPT, Gemini, Claude, or any other large language model, your ability to communicate effectively with these systems is the difference between getting generic results and unlocking truly useful outputs. In this first part of the two-part series, we're laying the groundwork. We've talked a lot on this podcast about how AI is transforming industries like education, tourism, and business. But we haven't stopped to explore how these systems actually work beneath the surface, or why prompt design is so crucial. Today, we're going to do that. We'll begin with the basics, how large language models and generative AI actually work. What does it mean when we say these models predict the next word? And why does understanding that give you an edge in writing better prompts? Then we'll explore the output configuration settings, the behind-the-scenes setting most people don't see but are important if you are serious in using large language models at an advanced level. Things like temperature, top K, and top P might sound technical, but they directly impact whether your AI gives you a creative brainstorm or a dry factual response. If you're building anything with AI, or even just experimenting, understanding these settings is a game changer. We'll also get into different styles of prompting. You'll learn the difference between zero-shot, single-shot, and few-shot prompting, and when to use each. We'll explore system prompts, contextual prompts, role prompting, and even a powerful technique called step-back prompting, which can dramatically improve the quality of your results by helping the model reason more effectively. And this is just the beginning. Next week, in part 2 of this series, we'll go deeper into the advanced side of prompt engineering, where things really get interesting. We'll explore how to instruct large language models to think more like humans using techniques such as chain of thought and tree of thought prompting, as well as other powerful methods that push the boundaries of what these models can do. If you want your AI to reason, reflect, and solve complex problems step by step, you won't want to miss it. We hope that this two-part series will offer some practical tips to help you start refining your own prompt engineering skills today, whether you're drafting marketing content, summarizing reports, writing code, or building intelligent agents. This two-part series is for anyone who wants to go beyond just asking questions and start using AI with precision, strategy, and intention. Because in the age of generative AI, your ability to ask the right question in the right way is just as important as the answer you get back. Let's get started.
Welcome to the Deep Dive. Today, we're embarking on a journey into prompt engineering. Now, for you, this isn't just about, typing a question into a chatbot. It's really about mastering the art of guiding powerful artificial intelligence, specifically large language models, or LLMs.
Right.
Think of it less like a simple chat and more like, conducting a very advanced orchestra. The prompts you craft are your baton, sort of directing the AI to produce the specific outputs you need.
That's a great way to put it. At its heart, prompt engineering is really about iterative refinement. It's a hands-on process of designing and tweaking your text inputs to really steer these language models toward generating accurate and high-quality results. It's fascinating because it's not just about what you ask, but the subtle nuances how you phrase it that can make all the difference. Many elements play a role in a prompt's effectiveness.
Like what kind of things?
Well, from the particular LLM you're using and the vast data it was trained on, to the fine-tuning of configuration settings, and even your precise choice of words, the structure of your request, and the surrounding context you provide. All that stuff matters.
And what's truly remarkable for you the listener, is the sheer scope of what well-engineered prompts can actually achieve. We're talking about the ability to distill lengthy documents down to their core assets.
Summarization, yeah.
Pinpoint specific pieces of information hidden within mountains of text, get direct and insightful answers to complex inquiries, categorize text with precision,
Classification tasks.
translate seamlessly between languages, whether human languages or even programming code, and of course generate entirely new code or creative text formats.
Exactly. So the mission of this deep dive is really to equip you with a significant advantage in understanding the most vital aspects of prompt engineering. We're going to concentrate on actionable guidelines and explore how businesses, in particular, can harness this knowledge to drive real value. Our aim is to move beyond just basic interactions and delve into how you can strategically guide these models for tangible, real-world impact in your work.
Okay, let's get practical then. One of the first things to grasp is that the text you type into an LLM isn't the only lever you have to influence its output. There's a whole set of adjustable controls operating behind the scenes. Let's start with something seemingly simple: the length of the response.
Exactly. You have control over the number of tokens the LLM generates. Think of tokens as the individual building blocks of language for these models. They can be whole words, parts of words, or even punctuation marks.
Okay, like word pieces.
Pretty much. By setting a limit on these tokens, you're essentially telling the model, give me an answer, but keep it within this number of word chunks. Now, it's crucial to understand that merely limiting the token count doesn't automatically make the response more stylistically concise. It simply tells the model when to stop generating text, which can sometimes lead to abruptly cut off answers. This is particularly relevant in some advanced techniques like React prompting, where you might want to restrict the output to prevent the model from generating extraneous, unnecessary tokens after it's given the core response.
Okay.
Just bear in mind that more tokens generally equate to more computation, which can mean higher costs and potentially slower response times for you.
That makes sense. It's like asking someone for a quick summary, but instead of them being more concise, they just get like silenced mid-sentence. Yeah, something like that. Now let's explore a more intricate aspect.
Sure.
How the LLM actually chooses the next word. It's clearly not just a random selection.
Precisely. LLMs function by predicting probabilities for what the subsequent token should be. For every potential word in its vocabulary, the model assigns a likelihood of it being the next in the sequence. These probabilities are then sampled to determine which word is actually produced. And this is where sampling controls come into play. The main settings you'll encounter are temperature, along with top K and top P.
Temperature. That sounds intriguing. Is that related to, like, how opinionated the AI might be? Or biased?
Not exactly in that sense. Think of temperature more as controlling the AI's willingness to deviate from its comfort zone of most probable answers. A lower temperature makes the model more predictable.
Okay.
It'll heavily favor the token with the highest probability, leading to more consistent and often more factual responses. This is generally beneficial for tasks where you're seeking, a single correct answer.
Right, like math problems or facts.
Exactly. Conversely, a higher temperature introduces more randomness. The model becomes more inclined to select less probable tokens, which can lead to more diverse, unexpected, and potentially creative outputs.
But riskier.
But it also increases the risk of the response being less relevant or even nonsensical for you.
Yeah. So a low temperature keeps the AI on a pretty well-defined path, while a high temperature encourages it to explore more winding routes, which could lead to interesting discoveries or maybe just getting lost.
It's a good analogy. Imagine having a list of potential next words, ordered by how likely the AI thinks they are. A low temperature heavily favors the words right at the very top of that list.
The obvious choices.
Right. A higher temperature makes words further down the list more accessible for selection. There's even a setting called greedy decoding, which is effectively a temperature of 0.
Zero randomness.
Pretty much. In this scenario, the model invariably chooses the single most probable token. However, it's worth noting, even at temperature 0, if two tokens have the exact same highest probability, which is rare but possible, the underlying tie-breaking mechanism in the code could lead to slightly different outputs sometimes.
Huh. Interesting nuance.
Yeah, it just underscores the inherent probabilistic nature, even in seemingly deterministic settings.
Okay, that's a useful distinction. Now, what about top K and top P? They sound like ways to narrow down the AI's options before the temperature even comes in.
You're spot on. Top K and top E are both techniques designed to restrict the next word selection to only the most probable candidates. Let's start with top K.
Okay.
With top K sampling, you instruct the model to only consider the top K most likely tokens. For instance, if you set K to 10, the model will only choose the subsequent word from the 10 words it deemed most probable.
Set the number.
Exactly. A higher K value introduces more variety and potential creativity because the model has a larger pool of options. Conversely, a lower K value makes the output more focused and factual, as it's limited to a smaller set of highly probable words.
And K equals 1.
Interestingly, setting K to 1 is equivalent to greedy decoding. Only the absolute most probable token is considered.
Got it. So K is like setting the size of the short list of potential next words. What about top P?
Top P, also known as nucleus sampling, operates a bit differently. Instead of selecting a fixed number of tokens, it selects from the top tokens whose cumulative probability reaches a certain value, P.
Cumulative probability.
Yeah, so P ranges from 0 to 1. If you set P to a very low value, say 0.1, the model will only consider a very small set of highly probable tokens whose combined probability adds up to just 10%.
So very restrictive.
Very. It's akin to greedy decoding. If you set P to 1, the model considers all tokens in its vocabulary, essentially. The core idea behind top P is to dynamically adjust the number of tokens considered based on their probabilities, aiming for a more natural and coherent flow in the output for you.
So top K is a fixed number of choices, while top P is a flexible number based on the combined likelihood. It really sounds like experimenting with both would be key to finding the right balance for different tasks.
Precisely. Often the most effective approach is to experiment with various values for both top K and top P, and some platforms even allow you to use them in combination.
How do they work together?
Well, when both are active, the model first filters the tokens based on both criteria. Only those within the top K and whose cumulative probability falls within P are considered. Then, the temperature setting is applied to sample from this refined set of tokens.
Okay.
If only one of top K or top T is available, that setting alone is used to narrow down the possibilities. And if temperature isn't an option, the tokens meeting the top K and or top P criteria are simply chosen from at random.
It sounds like these settings can interact in some subtle, maybe even complex ways. Are there any, extreme settings we should be aware of that could lead to unexpected behavior or make other settings irrelevant?
Yes, absolutely. At the extreme ends of the spectrum, one setting can essentially override or become irrelevant to the others. For example, if you set the temperature to 0, like we said.
Greedy decoding.
Right. The model always picks the most probable token, rendering top K and top P largely irrelevant. Conversely, if you set the temperature extremely high, well beyond 1, the temperature itself loses its influence, and the next token is chosen almost randomly from whatever tokens made it through the top K and or top P filters.
Okay.
Similarly, if you set top K to 1, only one token is ever considered, regardless of the temperature or top P setting.
Makes sense.
And if you set top K to a very large number, essentially encompassing the model's entire vocabulary, then any token with a non-zero probability becomes a candidate. The same logic applies to top P. A top P of 0 or a very small value will typically only consider the most probable token, minimizing the impact of temperature and top K. And top P1 means all tokens with any probability are in play.
That's really useful to know. It helps understand the boundaries of these controls. So as a starting point for different creative needs, do you have any general recommendations for these settings? Like where should people begin experimenting?
Yeah, sure. For a good balance that can offer some creativity without being too erratic, you might start with a temperature around 0.2, maybe a top P of 0.95, and a top K of 30.
Okay, moderate creativity.
Right. If your aim is particularly creative outputs, you could try pushing that higher. Perhaps a temperature of 0.9, a top P of 0.99, and a top K of 40.
More adventurous.
Exactly. For responses that need to be more focused and less creative, maybe dial it back. A lower temperature like 0.1, a top P of 0.9, and a top K of 20 could be a good starting point.
More factual, less random.
Precisely. And crucially, if your task consistently requires a single objectively correct answer, like solving a mathematical problem or getting a specific fact.
Start with temperature 0.
Start with a temperature 0. That's the best bet.
That's excellent practical advice. Now, you briefly mentioned earlier a repetition loop bug. What exactly is that and how do these settings play a role? Sounds frustrating.
Ah, yes, the frustrating repetition loop. It really is. This is a common issue where the LLM gets stuck in a cycle, repeatedly generating the same word, phrase, or even sentence structure. You might see a response that just trails off into meaningless repetition.
Ugh.
And this problem is often exacerbated by inappropriate temperature and top K, top P configurations. Interestingly, it can occur at both ends of the temperature spectrum, albeit for different reasons.
Both low and high temps. How?
Yeah. At very low temperatures, the model can become overly deterministic, rigidly adhering to the highest probability path. If that path happens to revisit previously generated text, it can get trapped in a loop.
Because it's too predictable.
Right. Conversely, at high temperatures, the model's output becomes highly random. This increases the chance that a randomly chosen word or phrase will, just by chance, lead back to a prior state, creating a loop simply due to the sheer number of available options and the lack of strong direction.
So too much randomness can also lead to loops.
Exactly.
Yeah.
Resolving this often involves careful tweaking of the temperature and k-top p-values to find that optimal zone between predictability and randomness for your specific task. It's a balancing act.
Okay, that's a crucial warning to heed. Find that sweet spot. So we've explored how to fine-tune the LLM's output through these configuration settings. Now let's delve into the actual words we use in our prompts. What are some fundamental prompting techniques that can significantly improve the results we get?
Right. So LLMs are trained on an enormous amount of text data and are fundamentally designed to follow instructions. The clearer and more direct your prompt is, generally, the better the model can anticipate and generate the desired output for you.
Makes sense. Clarity is key.
But beyond mere clarity, there are specific techniques that leverage how these models are trained and how they function internally to help you achieve more relevant and effective results.
Okay. Let's start with the most basic. I came across something called zero-shot prompting. What does that entail?
Zero-shot prompting is basically the simplest approach. It involves merely providing the LLM with a description of the task you want it to perform, maybe along with some initial text to get it started. The defining characteristic of zero-shot is that you provide no examples of the desired output format or style.
No examples at all.
None. For instance, you could give it a piece of customer feedback and just ask it to classify the sentiment as positive, negative, or neutral. That would be a typical zero-shot task.
Okay, simple request.
Now, as you begin to utilize prompts more strategically, especially within a business context, it becomes incredibly valuable to document them in a structured manner.
Ah, like keeping notes.
Exactly. This practice allows you to track your experiments, understand what's effective, and share insights with your team. A simple table format where you record, say, the objective of the prompt, the specific model you used, the temperature and other settings, the exact prompt text, and the resulting output. That's an excellent way to manage this.
That makes perfect sense. It's like maintaining a logbook for your AI interactions, allowing you to learn and iterate effectively. Now, what if zero-shot prompting isn't quite cutting it? I noticed techniques called one-shot and few-shot prompting.
Exactly. When simply describing the task isn't sufficient, you can enhance your prompts by including demonstrations or examples directly within them. A one-shot prompt contains a single example of the desired input and its corresponding output.
Just one example.
Just one. The underlying idea is that the model can learn by observing and imitating this single instance. Few-shot prompting builds upon this by providing multiple examples, typically ranging from 3 to 5.
Okay.
Although this can vary depending on the complexity of the task and the input length limitations of the model, how much text you can fit in.
Right.
These examples serve to illustrate the desired output structure or pattern you're aiming for. It's akin to showing someone a few worked examples of a particular type of problem before asking them to solve a new one.
Show, don't just tell.
Precisely. And the quality of these examples is paramount. They should be directly relevant to the task at hand, diverse enough to cover a range of potential scenarios, of high quality in their own right and well-written. Even a minor error in an example can potentially confuse the model.
Garbage in, garbage out, basically.
Pretty much. Furthermore, if you need your model to handle unusual or unexpected inputs reliably, those edge cases, it's a wise strategy to include examples of those edge cases within your few-shot examples to prepare it for a wider variety of situations.
Okay, so prepare it for the tricky stuff, too. Could you provide a concrete example of few-shot prompting in action, just to make it crystal clear?
Certainly. Let's say you want to develop a system that can take customer reviews of a product, maybe like pizza, and extract key pieces of information, like the specific toppings mentioned and the sentiment expressed towards them, maybe into a structured format like JSON.
Okay, parsing pizza orders.
Yeah. You could provide a few examples in the prompt itself, like input, loved the pepperoni, but the mushrooms were soggy. Output, pepperoni, positive, mushrooms, negative.
Okay, one example.
Then maybe another. Input, the crust was perfect, and the extra cheese was great. Output, crust, positive, extra cheese.
Cause it.
Second example.
Right. And maybe one more. Input. The delivery was fast, though the olives tasted a bit weird. Output. Delivery. Positive, olives. Negative. Then finally, you give it the new review you want to analyze. Input. While the sausage was amazing, I found the onions to be overpowering and the base was undercooked. Output.
And the model should follow the pattern.
Exactly. The model, having observed the pattern in your examples of how to identify features and their associated sentiment and put them in that JSON structure, should then be able to generate the correct structured output for that new, slightly more complex review for you.
That really clarifies how providing examples can guide the model towards the specific information and format you're looking for. Now, let's explore some techniques that seem to add layers of instruction. System, contextual, and role prompting. These sound like they're about providing more background and direction. You're exactly right. These techniques are all about incorporating different types of guidance to the LLM. System prompting sets the overarching context and objective for the model. It essentially defines the big picture of what you want the model to accomplish.
The overall mission.
Yeah, pretty much. Like specifying that it should function as a translator, a summarizer, or maybe that its output needs to adhere to a particular format. For example, you could use a system prompt to instruct the model, "You are an expert at summarizing technical documents." Then, when you provide the document in your specific request, the model approaches the task with that persona in mind.
Okay.
Or even more practically for business applications, you could tell it, classify these customer emails based on sentiment, positive, neutral, negative. Return the output in valid JSON format using the key sentiment. Ensure the sentiment value is always in uppercase.
Specifying format and style.
Exactly. And utilizing a structured format like JSON offers numerous benefits, especially for business use cases. It helps to organize the data, particularly when dealing with multiple pieces of information. More importantly, by requesting a structured format, you're essentially guiding the model to adhere to a specific structure, which can significantly reduce ambiguity and minimize the likelihood of it generating irrelevant information or hallucinations.
Fair weird tangents.
Hopefully. You can even leverage system prompts for safety and brand voice consistency, for instance, by adding a line like, "Be respectful and professional in all responses," or "All responses should adhere to our company's communication guidelines."
So system prompting is about establishing the fundamental rules and parameters for the entire interaction, maybe setting guardrails. What about role prompting? That sounds like you're actually giving the AI a specific identity to work within.
Precisely. Role prompting involves assigning a distinct character or identity to the LLM. This technique encourages it to generate responses that are consistent with the knowledge, behavior, and tone you would expect from someone in that assigned role.
Like method acting for AI.
Huh, kind of. For instance, you can instruct the model to act as a seasoned book editor, a friendly and enthusiastic travel guide, or a knowledgeable Python programmer. Once you've defined the role, you can then pose prompts that are relevant to that persona.
Okay.
So if you've instructed it to act as a travel guide for Amsterdam, you might then ask, "Suggest 3 museums to visit, focusing on art history." The model would then provide suggestions in the style and with the knowledge you'd expect from a helpful guide.
And you can make it fun, too.
Absolutely. You could prompt it. "You are a slightly sarcastic but ultimately helpful travel guide for Manhattan. Suggest 3 off-the-beaten-path activities." The response should then adopt that specific tone.
I see. So defining a role really sets the tone, style, and even the perceived expertise.
Exactly. It gives the AI a framework, which can dramatically improve the quality and relevance of its output for your specific needs. You can play with different styles too, make it confrontational, descriptive, persuasive, whatever fits the goal.
That's a clever way to harness the AI's vast knowledge base through a specific lens. Now, how does contextual prompting fit into this picture? Is that different again?
Yeah, contextual prompting is all about providing specific background information that is directly relevant to the immediate task you're asking the LLM to perform. This helps the model understand the nuances of your request and tailor its response more precisely. It's about the here and now of the conversation.
Giving it the immediate backstory.
Exactly. For example, if you're asking the model to draft some blog post ideas, you could first provide the context. "I wrote a blog focused on retro 80s arcade games. My audience loves nostalgia and technical details about classic hardware."
Okay, sets the scene.
Right. Then when you ask, "Suggest 5 blog post ideas," the model will understand the target audience and the key themes, leading to much more relevant and effective suggestions, like maybe a deep dive into the Pac-Man kill screen or comparing the sound chips of Donkey Kong and Galaga.
Much better than generic blog ideas.
Way better. By supplying this specific context, you ensure that the model's output is much more aligned with your objectives than if you had simply asked for blog post ideas in a general sense.
Okay, so system prompting sets the overall framework, role prompting gives it a specific hat to wear, and contextual prompting provides the immediate details for the current request. That makes a clear distinction.
Nicely summarized.
Now, there were a couple of other interesting techniques mentioned in the research. Step-back prompting and chain of thought. Let's start with step-back. What's that about?
Step-back prompting is a really interesting technique that can significantly enhance the performance of LLMs on complex reasoning tasks. It involves first prompting the model with a high-level, more abstract question related to the core problem, before presenting the specific question you actually want it to solve.
So you ask a broader question first. Why?
The idea is that this initial step back encourages the model to access and activate broader, more fundamental knowledge that might be relevant to the specific problem. By first considering general principles or related concepts, the model is sort of better equipped to tackle the more specific and potentially intricate details of your actual query.
Priming the pump with general knowledge.
Exactly. It's like asking for a general overview of, say, physics principles before diving into a specific engineering problem. The broader understanding helps to frame and inform the analysis of the specifics.
Can you give an example?
Sure. Let's say you want the model to write a compelling storyline for a level in a first-person shooter video game. Instead of just asking for the storyline directly, you might first use step-back prompting. What are some generally engaging themes or plot devices often found in successful first-person shooter game narratives?
Okay, asking about common tropes.
Right. The model might respond with things like betrayal, race against time, protecting civilians, discovering a conspiracy. Then you take one of those themes, say discovering a conspiracy, and feed it into your actual prompt. Okay, using the theme of discovering a conspiracy, write a storyline for a level set in a futuristic city where the player uncovers evidence of illegal government surveillance.
So you use the general answer to guide the specific request.
Precisely. This preliminary step can lead to a much more focused, insightful, and potentially creative storyline compared to just asking for one cold.
That's a really insightful approach, priming the model with foundational knowledge before posing the specific challenge.
Thank you for listening to today's episode. Just a quick reminder, this is only part 1 of our 2-part series on prompt engineering. If you found this first part helpful or you're curious about what more is possible, be sure to tune in to our next episode where we dive into advanced prompting techniques.